We're talking today about how to launch machine learning projects using something called MLOps. And this might be something you've heard of, it might not. It's a fairly new concept, really. And I'm going to be going over what that is and how it works. So as a quick introduction of myself, I'm the lead TinyML engineer, so embedded machine learning engineer at a company called Edge Impulse. I'll be showing you some of what we do later. I wrote a book on this stuff along with Pete Warden, who's one of the kind of founders of the idea of TinyML back a while ago. And I used to work on the team with Pete at Google on the TensorFlow team as when we launched TensorFlow Lite for Microcontrollers, which is a set of tools for building machine learning models that run on embedded devices like microcontrollers. I also work with the TinyML Foundation, which advocates for this type of technology. And I, in a previous life, founded a startup called Tiny Farms, where we were developing technology for raising insects as a sustainable form of protein. So I've done a lot of random wacky stuff, but I'm basically someone whose entire focus is on embedded machine learning, running machine learning models on embedded devices like microcontrollers and low-cost computers. So what I want to talk about for the next 30 minutes, and then we'll have some time for Q&A, is what on earth is MLOps and why is it necessary? I also want to talk about some of the features of an MLOps platform. So what is an MLOps platform and what does one do? And then actually I'm going to train one TinyML model because I've got a more interesting example that I figured out for this. And then I'm going to give you some resources for getting started. So one thing I wanted to note is that I really want people to ask lots of questions. I'm sure there's loads of stuff that I won't cover just from talking, and it'll be really good to hear what your thoughts are. So we should have lots of time for that. So please do ask lots of questions. So I want to get started by introducing the machine learning workflow. So if you've done anything with machine learning or probably with any kind of modeling, you will have encountered this type of workflow. Starts out with sourcing some data, then you're going to code a model somehow. You'll decide what kind of model you're going to use and write some code that implements it. You'll then need to train, evaluate, and tune your model. So this is the iterative process of running your data through the model, checking whether it actually represents reality, and then tuning it if it doesn't and trying again. You're then going to want to deploy your model. So that could either be to a little embedded device like this type of thing, which is what I'm very excited about, or it could be to a server somewhere, which is more traditional. So most machine learning models end up in some cloud server somewhere where they're fed requests and give their responses back in the cloud. You're then going to want to get predictions from your model by feeding in data and looking at what the output is. And then over time, you want to monitor what type of predictions your model comes up with and see if they seem correct. Does your model seem like it's producing reasonable predictions, or does it seem like it's producing garbage? And maybe does it need reworking? And then you're going to want to manage different models that you have and different versions of models that you have so that you understand which models are supposed to be doing what and what are the different iterations for each type of model that you've created. So this was taken from Google Cloud's AI docs. And I think it's really, they have some really good resources. I got some links I think we sent out in the email before this talk that give a good top-down overview of some of these concepts. So I recommend the Google Docs for getting a background on some of this stuff. Oops. So what I wanted to show you is that for each of these steps, there are multiple things that are parts of it. And a lot of these are artifacts. They're things that you need to track and keep a good hold on and understand how they fit into your project. So I'm going to go through a few of these so you can see how many there are. So when we come to sourcing and preparing our data, we have data capture code. That's the code that's capturing your data. We've got scripts that clean your data. We've got data munging scripts. So this is sort of all the process of like taking data from different places and integrating it together and getting it into the form you want to use to train your model. You want to use some scripts to explore your data. Maybe you want to graph some stuff, dive in and do some analysis of things. Then once you start coding your model, you've got experiments that you're running. You've got production training scripts, which are the scripts which are actually taking your model and training it with your data, maybe in some kind of big computer architecture you've got. You might be using a distributed infrastructure for training if you have a big model. So there's a lot you have to think about there. You've got scripts you use to tune your model and correct things about it and redo some things if you think you need some iteration. You've got some scripts and notebooks you might use to evaluate your model, so to see if it's doing its job correctly against the test data set. You've got all of the code dependencies of all of these things, so all of the different libraries and frameworks that they make use of. You've got model optimization code, which takes a model that's designed to just run on a server and maybe transforms that in a way so that it can run on a little device like this. You've got a runtime framework, so that's the thing that takes your model and runs it on whatever device you happen to be running it on. You've got, if you're writing an embedded application, you're going to need some embedded application code. You're going to need deployment scripts and build scripts that help you build a version of your application to run on that particular device. And then when it comes to getting predictions, you're going to need to do some logging on device to see how this thing's working. You might even need a server that you're going to write some logs to if you want to keep checking how the model is doing over time. And then you need some code to evaluate these predictions that you've logged and see if they make sense. And you might also need some scripts to retrain your model based on new data if you're finding that it's not performing that well anymore. And then you're going to need more build scripts to redeploy your model. And then you've got all these different models that you've trained and all these different versions of all of these different artifacts, which can be a bit of a nightmare. And so you need source control to look after those, and you need data versioning to even look after your data and help you understand, okay, this model was trained with the data set at the start of January, and since then I've added all these particular samples, and so this subsequent model is trained with all of those as well, and which one's better and which one works worse or better, and which data is used for each model. So there's a whole load of things, like a constellation of things to keep track of. And MLOps essentially is the art and science of keeping track of all this stuff. So oh, we've even got another one, so automated testing of your model to make sure it's working and functioning well in the context of your application over time. So there's this huge amount of stuff, and MLOps is basically the science of figuring out all of this and making sure that it doesn't blow your mind. Oh, why is it going back to the same slide? So, okay, here we go. This is MLOps. MLOps stands for machine learning operations, and this little contraction MLOps is similar to the contraction DevOps, which is developer operations, which is essentially like the art and science of running a complex deployed software installation. So MLOps is that same thing, but applied specifically to machine learning. And so it means all these things. It means running your ML workflow. So that's the thing I just talked through, end to end. And that could be locally on your computer. It could be in the cloud, on a cloud service. It means managing the complexity of all of these different parts. It means evaluating the results of what your models are producing and understanding whether they're fit for purpose, whether they're really doing their job. It also means improving your models over time. So how do you make sure that the models that you're training are getting better as you get access to more data and they're not getting worse? And tracking your deployments. So if you've got your model deployed in a bunch of different places in the field, how do you keep track of those? And I think that all of this stuff is really core to what makes machine learning projects successful, because a huge number of machine learning projects fail. And you know that in some ways that's okay, because essentially there's no way of knowing if machine learning is going to work for your problem without trying it a little bit. So it's natural that some percentage of these machine learning projects are going to fail, but a lot of projects fail because of uncontrolled growth in complexity. They fail because results are not evaluated properly at the stage they need to be in order to catch problems. They fail because a model is deployed that works well, and then over time it gets evolved and more data gets added to the training set, and it actually makes the model worse and it doesn't work as well anymore. Or the opposite, where not enough evaluations being done in the field, and the context, the environment changes over time and the model doesn't stay up to date with it. And so there's a load of reasons why these projects fail, and MLOps essentially is a bunch of tools that you can use to help take out some of those risks and make your project more likely to succeed. So I would say that MLOps is an ML workflow, which you always have, plus some degree of automation. So rather than having to keep track of all of this stuff by yourself or in a notebook or with post-it notes, you're using some kind of software tools to allow you to keep track of all of these moving parts and still do a good job. So traditionally, some of these tools could be custom scripts that you use to train your models. They could be frameworks that you are using, things like TFX, which are able to organize a bunch of scripts running on a bunch of computers. But the latest evolution of MLOps are end-to-end platforms that take all of these parts and give you a sort of one-stop solution that does all of them and has integration between all the moving parts to help you out along the way. And so Edge Impulse, the company that I work for, we build an end-to-end platform that does MLOps all the way from collecting your data through to training and evaluating a model. So the basic features of an MLOps tool include some way to manage and process data. So get data into the system, some way to train models. So actually training different types of models. Doesn't always have to be a deep learning model. It could be classical ML. There's some ways to version models. So keep track of, hey, this is a model I created one day. This is a model I created another. We can compare and contrast them. Some ways to evaluate and compare models. So how is this model actually performing on real world data? And some ways to deploy models. So this is when you're taking your model and getting it into a place where you can actually make use of it, whether that's deployed to an embedded hardware device or whether it's being deployed to a server. And as I mentioned, there's some big advantages to doing this stuff well. So the key thing is managing overwhelming complexity. So you don't have to think about all of those little post-it notes I had on my earlier slide. You can actually just focus on what you are trying to do, solving the problem, and let another system take care of all the details. It reduces the knowledge burden, so how much you have to know about and understand and be an expert in order to deploy ML models. And this is particularly important when you think about contexts such as conservation, where likely a researcher has a lot of domain knowledge about the problem, about the thing they're trying to solve, and they don't necessarily want to spend their time on learning all of the ins and outs of deploying ML models or writing code to draw pretty graphs to understand how your model is performing. So it really helps with making projects more feasible. It allows you to be more scientific, so you can run experiments, you can control different variables, you can tweak certain things while keeping other things the same. You can keep track of how all of that works over time, and you can do a really good job of that. So you can just go back and look at what you've been doing and understand what worked and what didn't, rather than it just being this sort of messy approach. And it makes long-term maintenance a lot easier. If everything's done in a structured way and a standard way, someone else can come along and pick up your project 6 months later and understand how it works. And it's always good to remember that that someone might be you, because as soon as you finish writing code on an ML project, you put it down, you've got it in a Git repo somewhere or in a directory on your computer. You forget about it for 6 months and come back to it, and it looks like code someone else wrote. You will not remember how it works, what it was doing, why you have this random variable that has a certain value that you carefully calculated at the time and you've now forgotten why it was even there. So it makes all of that stuff a lot easier, and it can also improve the performance of your models, because good MLOps tools can help you understand whether your model is working well and what you can do to improve it. So what I want to do now is give a little demo of the MLOps tool that my team works on. So it's called Edge Impulse. Essentially, it's a set of tools that do all of this stuff in this workflow loop. And it supports basically any type of data. So you could work with accelerometer data, you could work with audio data, image data. You've got pretty much any kind of time series of data, anything from radar through to sound. You can feed into Edge Impulse. And the thing that we focus on is embedded inference. So that's the idea that you are training models that are going to run on embedded devices, so microcontrollers or embedded Linux boards like the Raspberry Pi. So that's where we focus, that's where we shine, and that's really exciting for a lot of projects that are being deployed in the field in places where battery life and bandwidth are a concern. So I'm going to show you now, hopefully you'll be able to see my screen here. I'll make the writing a bit bigger. This is the Edge Impulse dashboard, and I'm creating a project here that I'm going to walk you through. What I want to do is classify whether a particular animal is present in a photo or not. So for some help here, I've enlisted my trusty assistant, Duval. He is a manatee. He originally came from the Florida Keys, and he now lives with me in my apartment. And I've captured a little data set of him. So I've got some pictures of Duval hanging out on my desk. Hopefully you can see him there. These were captured with an embedded device here. It's a Highmax embedded low power camera board. So it has a small low power microcontroller and a camera. And I also have some pictures of a background that does not have Duval in it, sadly. And what I want to do is train a model that can discern between background and a manatee. So this is obviously a pretty contrived example. I have a very small data set of 30 images. I have 15 with Duval and 15 with the background. And I captured these all in a few minutes yesterday. So what I can do with Edge Impulse is, the thing that we solve first is the data capture part. So I have my embedded development board here hooked up to my computer via USB cable, and I can just easily capture more samples. So if I click in here, I'm going to point the camera at Duval. Duval, you better pose nicely. And it took a picture, it's uploading from the device. And you see my new image here. This has been added to my data set. So it's just another sample of manatee. And that's how easy it is potentially to get data into a MLOps platform. Another thing you can do is, if you've got data that you've already collected, there's a ton of ways to upload that as well. So you can either upload it directly from your computer. We have some command line tools that let you do that. You can upload it from the cloud. So you can have it, if you have it in Amazon S3 or Google Cloud Storage or anything like that, you can basically just sideload it into Edge Impulse so it arrives in our system. And you want to collect both training data and test data. So the training data is going to help you train your model, and the test data, it should be the same kind of data, but it basically is going to be used for evaluating the performance of your model. And with Edge Impulse, you can either have the system split the data set for you automatically, or you can upload your own training and test data sets separately. So the next part of this, where we're going to define our model, that's super easy. So we have this block-based interface here where we automatically detect what type of data you're using. So here you can see we're working with image data. We then let you configure some stuff like the input size of the image. So your raw images might be huge and you might need to shrink them down a bit before you feed them into a neural network, because neural networks usually take surprisingly small inputs to be able to do the stuff that they need. you can then add some signal processing. So with images, it's very easy. We allow you to either have the image as grayscale, or we'll let you change the color depth if it was a color image to begin with. But with other types of data, we have all of these different signal processing blocks that do stuff. So for audio, for example, we have a few different blocks that can help you extract signal from raw audio that makes it easy for a deep learning network to understand. For motion data or time series data generally, we have a spectral analysis block, which creates a load of features that represent how the signal changes over time. And so you can also create your own signal processing blocks if there's something fancy you want to do. And that basically transforms the signal in a way that makes it more suitable to feed into a neural network. And then you can add a machine learning block here. So we have a few options showing up now for my image data. We can have a transfer learning block, which is really cool because it allows you to get away with using a very small data set and still have some good results. So I can show you that even with my 30 image data set, we got some decent results. You can also just use a raw neural network. We have a block-based UI for defining the neural network. I'll show you in a second. And if you are an expert, if you know a bit more about how to do these things, you can write your own code and run it in Edge Impulse, or use our templates as a starting point. And we also support classical ML, so you can do things like anomaly detection using k-means clustering, which allows you to find anomalous signals that are unusual compared to what the model was trained on. So once you've defined the basics of your model, you can go in and configure things. So for example, here's our transfer learning block. So you can see here that I've trained this model already on the data of manatee versus background. And I've actually got really good accuracy. So I've got 100% accuracy classifying my validation data here. And I have this really cool visualization that shows, like, basically we've taken all of these images and run them through an algorithm that projects the images onto a three-dimensional space based on their informational content. And the background images are projected in this light color, and the manatee are the more green color. And you can see there that you can see the difference. Most of the manatee fall in this portion, and most of the background fall in the other. And so that's a good sign. It shows that the data is something that can be, the different types of data can be discerned from each other. And you can see here that all of these samples were correct, and we managed to correctly classify all of those. So there's a ton of tools within Edge Impulse for doing this type of thing, evaluating the data, evaluating the results of your training, and seeing whether it works. And if you were to end up with some problems, you'd see plotted on this chart, you've got a few points maybe that are showing up red that are things that weren't correctly classified. And you can click on those and find it individually. Say I was interested in this point, I can click on it here, and it shows up at the bottom of my page. So if there were some pictures that weren't working correctly, I'd be able to look at them and see, oh, is there something special about this particularly that means it's not working? So we also give you an estimate here of the performance on device. I don't know why this image is overflowing there, but we can show how your model is going to perform on a particular embedded device. And so right now, this is going to take less than a second to run. It uses about 296K of RAM and 586K of ROM. So that gives me an understanding of if it's going to fit onto the device that I want to use. So another really cool thing I can do is live classification. So if I want to test out my model, just do like a smoke test. I've got Duval here. He's ready for some more fun. So I'm going to put him there. I'm going to click Start Sampling. And now hopefully Duval is going to be correctly classified. And yes, he was correctly classified as a manatee. So that's a super quick and easy way to test my model. But what I can also do is use this to add more training data. So the expected outcome there was manatee. So I can put that in, and this now becomes part of my test data set, which I can use to evaluate the model. And if this came up as an incorrect classification, if it classified poor old Duval as background instead of a manatee, I could set expected outcome to manatee and add this to my training data set so that next time, hopefully, the model will be trained on this and it will not misclassify the image. So just to make sure this works, let's do one with the background. And you'll see how this is different. So Duval's moved himself out of the way and the outcome was background. And you can see the probability distribution here. So we give you kind of the detailed results. You can also see how this particular image falls in our overall cluster of inputs. So you can see this one, it definitely falls in an interesting spot. It's not really in the same place as the other manatee samples in our visualization, but it still gets correctly classified. So that's kind of a good sign that our model is able to generalize. So once we've got this nice testing data set figured out, we can run a big test over all of our test data sets. So I've already run one here. So I basically have a list of all the test data here, and bear in mind this could be a huge amount of data. We recommend it being about 20% of your overall data set. So for mine it's quite small, but if you have a big data set of lots of samples, use 20% of that, you hold it back at the end and use it to evaluate the accuracy of your model. And you can see out of my 10 samples that were tested here, 9 of them were correctly classified, so 1 of them wasn't. And so I've got an accuracy of 90%, and I can drill in and have a look at what was up with this particular item. So we're going to load this one up, and it looks like it's from a different spot on my desk. So rather than the place that all of my background images were taken from, or most of them, I took this of a different part of my messy desk. And because of that, it was incorrectly classified. So I know from that, hey, my model isn't able to understand things that deviate from the main place most of the samples were taken. So that gives me a clue that, hey, I better try and add some more training samples that represent more diverse backgrounds, because otherwise my model's going to fail when it goes out of the lab. And you can see that here on this diagram. This point has sort of ended up in a corner that's kind of far away from everything. So the model really didn't know particularly what to make of it. And it just sort of decided it was a manatee. But what I can then do, I might say, okay, I want to add this to my training set. So hopefully now I have a bit more data about what a background can be. So a couple of extra things I want to show you. So when we come to deployment, we can deploy a model automatically to a lot of different places. So because this is a vision model, there's a couple of targets I can choose, and I can literally download a firmware that deploys to this device, and it will work on the device without any additional engineering. The other thing I can do is output a C++ library or an Arduino library that will run on the device inside of your application. And so this will work on anything that supports C++11. And you can also download some WebAssembly code, and this will run on very easily on any kind of embedded Linux device that supports a JavaScript runtime. And what we might want to do then, once we've deployed a version of our model, we can create a official version within Edge Impulse, give it a description. So Duval's first adventure in deep learning. And I can store this version, and it will save it, and it will basically mean that I can go back to that version at any time and deploy it, and I can compare it to any new version that I've made changes on, so that over time I can make sure that I'm always improving and that I'm always getting better and better performance. And if there is a regression introduced, I can go back to a previous version and see what went wrong. Another really cool thing is you can make the version public. So if you wanted to share with other people, you can share your whole ML project either with like the conservation community generally, or you could share it just with some specific other people who you work with. So that kind of gives an end-to-end overview of an MLOps tool, which is Edge Impulse. And I'm biased. I think this is the best MLOps tool for embedded and embedded Linux. But there are other tools that do similar things out there. But what I kind of wanted to drive home in the last couple of minutes of my formal talk is that you are always doing MLOps. All of the things that you're doing when you work with machine learning, whether you're doing it in your just a single Python script with no version control or anything, whether you're using a IPython notebook, whether you're running some stuff in the cloud, you're always managing all of this complexity. You're always doing MLOps. So if you want your projects to work and be maintainable, you should make sure you do this well. And a really good way of doing that is finding a framework that can help you, because then you just don't have to think about a lot of the moving parts, and it can help make your project a lot more likely to succeed. So I'm going to leave up some resources here on the screen that are potentially helpful on getting started with Edge Impulse. So depending on what type of data you're working with, we have a few different tutorials here, and you can get up to running very quickly. We also have public projects for each of these, so you can just load it up and have a look at how it works. And we have a really awesome forum with a ton of people helping each other out, and we're very active on there providing support. So if you have any questions about this type of stuff, great place to post it. And we're especially excited about applications in the conservation space, so we're always excited to engage and help. So that's everything from me in terms of slides and demos, but I'd love to see if anyone has any questions.
Fantastic. Thank you both, Dan and Deval, the Manatee assistants, for showcasing such a useful set of tools for ML projects through such a thorough tutorial. Just so the audience knows, the resources on the last slide are available on Dan's episode page on the WILDLABS website if you want to look them up at a later stage. So I'll just jump right into questions. I'm going to start with one opening question. It's a little different. So last week we had Ed and Melanie from Bear ID do a presentation on ML and more specifically collaboration between the tech and conservation sectors. So I've heard MLOps being described as a culture or a practice for collaboration and communication between data scientists and operations professionals to help manage the ML lifecycle. So my question to you, Dan, is from your perspective, what do you wish conservationists knew when going into a collaboration with an AI team? And what, in your experience, are the barriers to this collaboration?
Well, that's a really good question. And I think it kind of speaks to the heart of some of this stuff about, like, how do you make a project successful that is using ML? And I think what I would say is that the thing that like drove me and got me excited to get into this area in the first place was working at a company like Google, where we have all these people, like thousands literally of ML engineers working together, developing tools that are designed to allow people to do the hard work, like of running machine learning tasks, training models, evaluating models, all of the technical stuff. But we don't necessarily have the in-house expertise on all of these domains that people want to deploy this technology to. So I kind of noticed there's this really big gulf between people who know ML and people who would consider themselves machine learning engineers, and people who are domain experts in the problems that people want to solve and that need to be solved in the real world. And the thing that's really cool about MLOps is it gives kind of this shared language and like an interface between those two groups of people. Because as much as, you know, in an ideal world, we would all know everything, and the person who's an expert on a particular ecological niche that they want to study is also an expert in building and deploying machine learning models and distributed cloud infrastructure and then deploying them to embedded devices. But realistically, nobody has time to be an expert in all of those things. And so what I think is good to know is to have an awareness of this ML life cycle. So have an understanding of what does it look like to train and deploy a model, only at a very high level, but understand that this is the type of workflow where I actually, this one is a little bit imperfect because the main feature of it is this loop. So the loop, which is encapsulated on the previous slide as train, evaluate, and tune your model, is a key part of this. And we definitely don't have a situation where you just get data and then train a model and then you're done. This is really an iterative process where you're experimenting, trying lots of things out, getting more data, trying new things. It takes a while sometimes. Like any software project, pretty much if you ask for an estimate of how long it's going to be, the number you get is going to be wrong. And having an understanding of the way that workflow works and what it looks like when you're working with an engineer and when you're working with an ML engineer is going to be super helpful in setting your expectations for like how you're going to need to engage with them, when you're going to need to engage with them, whether you can't just kind of hand off a load of data and expect that magically 6 months later they'll come back with a working project. It's more like this kind of continual dialogue. And if you have a little bit of understanding of this workflow, even if you're not going to be doing that work yourself, you'll have a lot more, it'll be a lot less stressful trying to figure out what's going on. Why does this still not work? Why have we tried 10 things and we still can't get this working? Sometimes that's just how it goes. And a good way to learn that yourself is even if you are planning on working with an ML team on some of this, you can easily open up Edge Impulse and go through our tutorials and train something in like 10 minutes at home. So that can give you a good understanding of like what the process is like, and maybe that lets you work a little bit more easily to get your critical domain knowledge applied to this problem alongside someone whose domain knowledge is on the ML side.
Thanks, that's a great answer. Yeah, I can see just from some of the comments in the chat from people who are less familiar with ML, myself included, some of the jargon was a little bit scary initially. So yeah, I think so many of the points that you mentioned make a lot of sense in terms of like building that sort of iterative, collaborative process.
Yeah, actually, just to add to what you said around the jargon, I mean, that's totally true. And I think until recently, I'm a firm believer that the best way to learn things is by doing them, especially with technology. And for me personally, I literally can't remember anything unless I've done it several times. So I think that until very recently, it's basically been impossible to learn by doing ML without investing months and months of study and work. And now with tools like Edge Impulse and with other similar tools that do similar stuff in different veins, you really can, as an individual with no background whatsoever, you can dive in and get your hands dirty and learn some of this terminology by doing it and playing with it and seeing it in tutorials and seeing it in our user interface. We actually have a Coursera course that we're launching very soon that's going to be a super easy way to get started building ML stuff. So I'll be sharing that on social media when it's available. But it's if you do feel that like, oh my God, what is all of this craziness? That's totally fine and natural. A couple of years ago, it would have taken you a couple of years to not feel like that anymore. But I think now maybe it could take you a week or two of playing and experimenting in your spare time.
Oh, great. We'll definitely keep an eye out for that Coursera course and share it on WILDLABS as well.
Awesome.
Before I move to the next question, would you mind stop sharing your screen? If you want to reference some slides again, please do share again. It just sometimes helps make the recording a little better. Thank you.
Awesome.
So I think we're going to actually bounce straight to the one and only Steph for a follow-up question.
Okay. So I asked if I could jump the queue, close my question. related to the discussion you were just having about learning the lingo, and we were having a chat in the chat about how useful your talk was to just get to know a lot of the terms from that come from your side of the fence over to the conservation side. But I was wondering, people, when we're talking about ML, and this might be a stupid question, I'm sorry everyone, so many people talk about pipelines and building pipelines. And the thing that you, I know we should definitely start an ML and ecology course. Sorry, you know, when the slide that you showed up first, and then it kind of blew everyone's mind about how much stuff is that a pipeline? Is that what they're talking about? When
so exactly, that's a really good question. So yeah, the pipeline, essentially, if you think of any data project as being starting with the real world and ending with some kind of insight that has been gleaned using technology, some technology or other. And so the pipeline is a series of transformations that happens to that data as it goes through the system. So it starts out with whatever is collecting the data and encoding it digitally. Then you may be analyzing that data, figuring out what you can do with it, transforming it into a way that you can maybe use to train an ML model. Maybe you're just transforming it in a way that makes it easier to store. But whatever you're doing with the data, then maybe you're training a model, then maybe you're running the model on other data that's coming in from wherever it's coming in from. And eventually you're coming up with some conclusion. Sometimes it can be a simple thing like whether it is Duval or not in a picture. So other times it could be like a report or something very, very complex that you're generating. And that end-to-end flow is generally referred to as a pipeline. And it's essentially a bunch of steps. It's not necessarily like a nice, clean pipeline that happens automatically. It's essentially a bunch of steps that successively transform raw data into something that's useful for whoever it is that you're building the pipeline for.
Right. Okay. That's really helpful. Thank you. I've been wondering that for a while. Okay.
Yeah, that's a very good question. There's a lot of weird metaphors in this space that people who have been doing it for years aren't even aware that they're metaphors anymore.
Yeah. It's the same thing for conservation. Like there are so many, like we're working on a big project that's got both sides in it, and just we had to have a dictionary to translate like just assumed knowledge in different terms. Anyway, I'll give it to other people. There were lots of questions. Thanks, Jen.
Indeed. So our next question is from Daniel Boschen. I hope I pronounced your surname correctly.
Yes, hello. Thank you for this introduction. And I'm very impressed by the transparency of your workflow. We are working at ETH and University of Zurich to track bees at the entrance. There we want to see what pollen color they bring in, and so we can have a kind of analysis of the diversity of the plants around in this combined with other things. Now, can different groups work with your system? Because one group is using TensorFlow and the other one is using YOLO version 4, for example, something like that. And we had always the problem that if a group of students started with the project again, they needed about 2 months to understand how to work with it. Would that be possible with your system?
Yeah, so in terms of basically working with a group, you mean?
Yes.
So yeah, absolutely. So there are features in Edge Impulse that allow you to have a project and add collaborators and work together with a team of people. So that's one way you can do it. The second way you can do it is you can create a version of your project and share it with people. So I showed that versioning system and talked about public versions. So that's how you do that. So I could create a version of my project that I've been working on privately. And if I wanted to share it with you so you could get an idea for the work I've done, I could just make a public project and send you the link. And you can also do that more privately as well if you don't want to share it with the whole world.
and you can connect this to the cloud system like Azure or something like that, because our goal is to collect all this raw data, which is about 65 gigabytes data per day, because we have 25 seconds every pictures, you know. We have spent a lot of time and money to annotate this kind of piece and to create these models, and we are eager to share it with the community, with the goal, of course, to challenge people to find algorithm which is faster, because at the end we don't want to use it, we don't want to download all this data to our service. The goal is to use an edge device at least, you know, but if you don't have any raw data, you can't work with it, you know.
Yeah, so I mean, we have a ton of features that I didn't show that are based around integrating with cloud data storage, transforming data and taking it from the cloud into Edge Impulse, and then exporting data from Edge Impulse if you want to use it in other places. And everything that happens within our product can be done using an API as well. So if you wanted to automate that pipeline of taking in data every day, retraining a new model, and then exporting that somewhere or deploying it to a device, you can script all of that too. So it sounds like it would be pretty well suited, actually.
Cool. Thank you very much. And how expensive is it? What's the price?
It's worth, it's free for the vast majority of our features are completely free for everyone. The one thing that we do charge for is that data integration with like data warehouses and that type of thing. And so what I would do, I don't know the pricing stuff off the top of my head because I just build things. But if you drop me an email at dan@edgeimpulse.com, I'll connect you with someone who can give you all the details for that.
Okay, I will.
It's not super expensive.
Thank you very much.
Thank you. Awesome work, by the way.
Thank you.
Thank you for your question and sharing your research. Next, we have Christian. Christian, you're welcome to ask both of your questions if you'd like. Christian, are you there? We might have lost him. No? Okay.
Tatiana, do you want to just ask the question for him so I can catch up on the recording later?
Yes, I can. So Christian asked, is Python recommended for ML approach? I use R, but I know that some packages are able to work on ML environments. The same could be possible to do with an object like a WAV file.
It's a good question. So I've done a bunch of machine learning stuff using R. It's really great for some things. I'd say with classical ML, so things that aren't deep learning, there's some really cool tools in R and you can be really productive. For deep learning, which is anything involving neural networks, essentially, I recommend Python as the place to go because you've got all the big frameworks there, things like TensorFlow, PyTorch, high-level frameworks like Keras that make it really easy to build these types of models. So if you're fine using things like linear regression, like random forest, classical ML algorithms, stick with R if you already know R and you don't want to spend time learning another ecosystem of tools. But if you want to do some deep learning, I definitely recommend learning some Python. And there's some really good courses out there on how to do that. You can also do that stuff within Edge Impulse. If I can just very quickly share my screen again, I'll give you an example. So give me 1 second. Sorry, I'm slow.
No worries.
Okay, here we go. So this is an example of a model that's trained within Edge Impulse. So we have a model that's working here that's classifying some different physical motion. And you can see one of the modes we have within Edge Impulse, you can actually just write Python code to implement a model. And we will allow you to, if you go to the simple mode, you can see the model is defined using a visual editor here, which is really cool, and you can add layers. So if you kind of sort of know what you're doing with machine learning models, or you do know what you're doing and you just want to be quick, you can build a model using this block-based interface. But if you want to go deeper and do some custom stuff, you can switch to a Keras mode, which is our expert mode. And here you can edit the source code of the model directly and run it just the same. So you get all of the benefits of all of the stuff that we do to manage the complexity of the overall system, but you can have full flexibility and freedom to define the model however you like. So that's a good place to learn, because you can experiment with the relevant stuff without having to learn all of the accompanying glue code.
Okay, next we have Roger, who doesn't have a mic, so I will ask his question for him. He just wanted to know what the name of the board that you showed in the demo was.
Awesome. So this is the Highmax. Let me see what the exact model. It's the Highmax HX6537A WEI plus. So let me paste that maybe in the chat for you. And in fact, I can find you our blog. We have an article about it too. So is this the chat? Yep. So I posted the model number in there, and then I'm going to track down the blog post for you as well.
Thanks. Sorry, this is Roger. I don't know if I could fix the mic. Oh, it seems like I did. Oh, thank you. So, and I just wrote it. I would like to add to the question whether if the ESP32 boards, which also feature a camera, can work same way, more or less, or.
Yeah, they can. So the good thing with this Highmax board is that we've written all of the drivers for the video as well, or for the image sensor. So there's two classes of support we have in Edge Impulse. The top level is, the basic level. So pretty much any device that has the ability to run some C++ code, you can run your Edge Impulse model on. But for certain devices where we work as partners with the company that makes them, we actually have our own firmware, so you can do everything like connecting to the device and taking pictures from it. Like I was showing, you can export a firmware that runs directly on the device without having to write any of your own application code and that type of thing. And for those, we support a subset of devices. You can see those on our documentation. I'll get you the link for that as well. If you check out this list here, and we're adding these all the time. Our goal is basically to have a dev board from all of the leading silicon manufacturers. So we're getting there. We've got a bunch coming up as well. So you can run Edge Impulse pretty much anywhere as long as you've got enough RAM. And if you have one of these supported boards, you get that full end-to-end experience.
Okay, that's super nice that you made that integration, and I see there is quite a big amount of devices supported, which make it excellent for us. Thank you very much.
Awesome, thank you. I'm glad it's useful.
So I see we are rapidly approaching the hour. I just want to check, Dan, if you're okay. We've got a few more questions still.
Oh yeah, very happy to stick around.
Fantastic. So our next question is from Carly.
I think I asked like multiple questions. Unclear. Well, I'm just gonna ask them all.
Awesome.
Tatiana, what is the question? Hi, Dan. Tatiana, what is the question that you're referring to at this moment?
Integration with Google.
Ah, yes. I think when we were emailing, you said there wasn't Google, because I have like all of my data backed up in a Google Drive folder. So does that now work? You were saying like it was only Amazon.
Good question. So yeah, right now we have an integration ready to go with S3 that you can connect to. And for the Google integration, we're basically waiting for someone who's able to buy an enterprise subscription that will like give us an excuse to do that work, to do the Google Cloud integration. So we don't have that. Even with the S3 thing, that's something that's dependent on an enterprise subscription. And so it's not something you can just sort of find in our user interface. But when we have demand for the Google Cloud one, we'll be able to justify adding that. Basically, it's something that's going to take like an engineer on our side a little bit of time to hook up the first time we do it.
The lemurs demand it. Is that not enough?
It's enough. It's enough for me, but you have to talk to my boss.
Listen, I can sell anyone on lemurs. Give me 5 minutes. Oh, they'll be sold.
Carly, I think you also had a question about AudioMoth integration.
Yes, I've heard like random rumors that you're working with the Open Acoustics guys to integrate AudioMoth as a board, I guess.
Mm-hmm.
What's the status of that?
Yeah, so we're still in the kind of early stages of working together with them and figuring out how that's going to look. But the Edge Impulse SDK does run on AudioMoth. They've taken our SDK and been able to.
Wait, pause. SDK means.
Oh,
what?
sorry. Yeah, so that's the C++ code that we generate that contains your model and the signal processing code that's required to run it. And so that's the thing that you would deploy onto the AudioMoth in order to run your model on there. Sorry, I use these things just unthinkingly without kind of recognizing that it's hard to understand. But yeah, so we've been working with them on kind of figuring out how that could look in terms of a deeper integration and what needs to be done to make it easier, because there's a little bit of sort of fiddling around that needs to happen to make that work. But that's on our roadmap and on their roadmap. So there should be some cool stuff coming out of that over the first half of this year, I hope.
Okay, cool. Did you fix the bug? Can I upload 60-minute files now?
I'm not sure yet. I will double check and let you know.
Thanks.
Awesome. Thank you, Carly.
So our next question is from Rob.
Thank you, Dan. I didn't think I was going to get a chance because of Carly, but you answered those questions brilliantly. Just kidding. They were great questions. I was actually really interested to hear that you are working with the AudioMoth guys, but it's already running on the AudioMoth. So that's a great piece of news. My question is a little bit boring maybe, but in your presentation, you had a graph where you had looked like 3 axes with your data presented. And each of the axes said something along the lines of visualization identity or something like that. What these actually give us some idea of what data were. Am I cutting out? Because it looks like I'm cutting out.
Yeah, you're cut out a little bit, but I got your question.
Yeah.
So what we are doing is something that I'm sure some people in this chat are aware of. It's something called UMAP, which stands for Uniform Manifold Approximation and Projection for Dimension Reduction. And essentially, that's an algorithm that takes in a bunch of inputs, and then it kind of learns how to represent those inputs that may be very highly dimensional. So, for example, an image, it might have like thousands and thousands of individual pixels, each of which is a dimension, and it boils it down into a low dimensional representation where you can still tell these different things apart. And so I'll paste in a link to this. So what we do basically is when you upload your data into Edge Impulse, we and do your signal processing, we then run that through the UMAP algorithm, and we're able to get a point in that three-dimensional space for each of your data samples, and so we can plot them there. And so the axes, they don't really mean anything. It's just a value that represents the position on that axis of that particular sample within that reduced dimensionality space that UMAP produces for our data set. So this is something that's used in a bunch of different places in science where you're trying to understand, like, how do complex things relate to each other. I've seen it used for things like plotting genetics data, which would otherwise be very difficult to visualize. And so we thought it would be perfect for plotting some sensor data from embedded devices too.
Yeah, okay, thanks, Dan. That's very helpful. Cheers, mate.
Awesome. Thank you.
Okay, and our final audience question is from Robert.
Oh, hello. Can you hear me?
Yes.
I've got a number of questions because the more you talk, the more questions pop up. The top one's a bit of an overview question. Just so I understand the process, Edge Impulse, do you provide the computational training time? So you're picking up, I mean, I post a bunch of data up there and you're going to flip the bill for all the computational time to creating a model, and you're going to give me a beautiful inference model that fits on my board.
Yeah, great question. Yeah, that's exactly right. So our model is essentially that we have a free product for the vast majority of developers, and then we have enterprise subscriptions that give you access to some of the more the features that you need for dealing with much bigger data sets and with collaboration within organizations. So for most developers, they don't necessarily need that stuff, but a few do, and they're able to support us so that we can provide a free service for everyone else. So computation is free. We do have some limits, but generally people don't run into them. It's more for kind of our protection in case something went wrong. And if you did run into a limit in the platform, you can just send us a message on the forum and we'll just disable the limit for your account. We just don't want people mining Bitcoin on our system or whatever. So yeah,
I can sell a graphics card on eBay.
Yeah, exactly. So the thing that's helpful for us is that we deal with tiny models, right? We deal with models that run on embedded devices with like 500K of ROM. So most of the time, it doesn't take that long to train these models. And we have a lot of special tricks that we use to make it faster to train models that also help. So we essentially don't end up running up as huge bills as you might if you were training these like giant vision models that are taking huge inputs and are like 30 meg in size. Our models are all in the kind of sub couple of megabytes. And okay. So yeah, you should feel free to jump in and upload some data and try some stuff. And if you do end up having a particularly big data set that's difficult to work with, let us know and we can figure something out.
Yeah, well, I noticed that somebody in the chat just mentioned ecoacoustics, and these files are really big, really big. They take a lot of computational time to make an inference model that you could fit on a microcontroller.
Yeah, so one thing that I like to point out is often you have a lot of data, but if you look at the subset of that data which is actually labeled, it's a lot smaller. So you can kind of think of a distinction between the data that you have that's in your labeled data set and then your entire kind of massive data set that you've collected but haven't listened to, haven't labeled yet. And so there are ways of kind of bootstrapping. If you've got like a small labeled data set, you can then use that to label your larger data set. But I think often when you think, oh, I've got so much data, this is going to be so difficult and expensive, you have to think about like how much of the data is going to be used to train the model, and that part is actually usually smaller. And if it's not, you can maybe get away with using a subset of that giant data set, depending on how diverse the classes are.
Okay. The other question was in your dashboard, where you give the size, does that include the size of the SDK and everything that Edge Impulse will be putting on to your board?
Good question. Yeah, it does. So you can see there's a couple of different estimates in different places. So we have two parts of Edge Impulse. There's the signal processing, which feeds into your model, and then there's the model itself. And we'll give you the individual breakdowns for each of those. And then in deployment, you can see the totals for them combined.
Oh, cool. And then the last easy question, I think. So I've got a lot of code from my machine learning stuff. How do we write a plugin for Edge Impulse? And are you restricting what language we use?
Yeah, good question. So absolutely not. So what you can do is if you have, for example, some signal processing code, you can basically define, I don't know if you're familiar with Docker.
Yes. Mm-hmm.
So you can write a Docker container that includes the code that you want to execute, and then you can just upload that somewhere, add a link to Edge Impulse to that Docker container and whatever authentication stuff you need, and we will pull that container down, build it and run it in our cloud infrastructure. So essentially you can write whatever you want, whatever language you want, whatever dependencies you need, as long as you can grab them over the internet within the Docker container.
And we will then in the Docker container as well.
Yeah, you can do that too. So when you've got, if you've got like particular scripts that you need to use to deploy your model, you can throw that in the Docker container and point our deployment process to that as well.
Oh, that's great, because they're all in Julia.
Yeah, awesome. Well, so all of that stuff, there are integration points, and with the deep learning stuff, we don't have that just kind of plug in URL. Yeah, it's mostly with the signal processing and with deployment, but that's something that we're going to be looking at in the kind of medium and longer term. Right now, the way we support extensibility for the neural network itself is using Python in that inline editor that I showed, or you can download an IPython notebook that implements your model.
Great. Well, thanks. This looks absolutely terrific. It should have been here a couple of years ago, but because I've had to write all this stuff myself, and you've clearly done a much better job than I did.
Oh yeah, well, I mean, we got sick of writing it ourselves too.
Yeah.
So. Oh, thank you very much.
It's thankless work, but this is a great job. This product looks absolutely awesome.
Thank you. That means a lot.
Thanks. So I can see that there's been a lot more questions coming up in the chat that have been triggered by this discussion. I'm going to bring the episode to a close shortly, but attendees are always welcome to stick around in the after hours session, as well as make use of the episode forum thread on WILDLABS, where you can drop in your questions and continue the discussion there. So just as a closing question, we've started asking all our tech tutors a bit more of like a horizon scanning reflective questions. So I just wanted to ask you, what is the next big development in the application of machine learning and conservation that you would like to see? Or what's on your radar? What do you think's coming up?
Yeah, that's a good question. And I can start with what I'm most excited about that we're working on. So we're working on a really big feature at the moment that, if you think about what I showed you today, we've had this idea of like sensible defaults. So the idea is you should be able to upload your data, click through a bunch of things, not worry about any of the configuration, and it should just work to some degree. But there's always a more optimal configuration of a model and of signal processing that's going to get better performance. It's going to run faster. The model will be smaller. It will have a better accuracy. And generally, to find that, you have to do a lot of iteration and playing around, like I mentioned, in this iterative loop and tweaking things and seeing what happens. So we're about to launch a feature very soon which takes care of all of that for you. So we're calling it Eon Tuner, and it basically tunes all of the parameters of your signal processing algorithms, of the deep learning model, and trains a bunch of different variants which each has slightly different parameters and figures out automatically which one works best. And so you're essentially going to have the equivalent of like a team of ML researchers iterating on your problem just by clicking a button and waiting for half an hour. So I'm very excited about that. I think that type of tooling, it's existed in the world for a while under the name AutoML. It's the general concept of doing ML automatically. But where we do it differently is we take it all the way down to the signal processing and the data capture part with embedded devices in mind. So you can say, hey, I have a budget of 200K of RAM. Maybe you have a budget of 10K of RAM and 10K of ROM. What is the best possible model that will fit? Sorry, I just saw Paul's comment asking whether I said Eon Tuner, and it's Eon, E-O-N, tuner, as in like a guitar tuner. Yeah, we go all the way down to the low level and understand like what is the impact that these little tweaks are going to have on how long it takes your model to run on a particular embedded device, or how much memory is this going to consume on a particular embedded device. And it's kind of amazing because that stuff has required so much domain expertise up to now, and it's going to be something that's within reach of everyone who has a data set. So that's very exciting. And I think then speaking to like what I'm most excited about generally in the long term is data sets. So one of the things that is most challenging about an ML project and starting a new ML project is that access to data is really hard. Whether it's that you've got to go out in the field and get the data, or whether it's just that dealing with these huge volumes of data is very difficult. I think that we need to work together as a community of people who are working in the field and working with existing data sets and ML engineers, and come up with better ways of managing data, sharing data, annotating data, being able to build on top of the data sets that we already have rather than starting from scratch every time, thinking about what is it important, what kind of metadata is important to collect when you are collecting data, so that you don't go out and collect 1,000 hours of audio that no one else can make use of because it only contains information that's pertinent to your project. So I think there's going to be kind of an evolution over time of these like protocols around collecting and sharing and managing data that hopefully are going to be easier to develop now that we have easier to use tools for the ML part. And sorry, there's some hilarious jokes going on in the chat. Keep distracting me. Yeah, like, and then having the software tools to evaluate data sets and better understand, is this data set going to ever be able to give me the model performance that I need? And if it doesn't, what type of samples do I need to add? Where is my data set lacking, and where do I need to fill in the gaps? So I think that's really where I think a lot of potential lies. And if you talk to most sort of people about ML, they say that the algorithms are one thing. That's the thing that gets all the attention. But the really important thing is data sets. And I'd add to that, okay, data sets are really important, but MLOps is just as important. But as we get better at that, and as we work together as one big community on figuring this stuff out, I think that's going to be what's going to unlock amazing applications in the future.
Fantastic, thank you. And thank you so much, and as well to Dhaval, of course, for such a thorough Tech Tutors episode. It's been great having you again.